Hello, everyone. So I've spent more time in data engineering than data science. And I just want to startle you with a question. What percentage of data science projects or programs do you think succeed or complete? Let's start with that. What is the percentage of programs or projects that a large data platform or project succeed? 10%? 2%? And? Okay. So now let me rephrase the question. What percent of projects finish or see completion? So it's 85% failure rate. Only 15%, so whoever said 10 is close to the number. 15% of the projects just get completed. How many of that 15% create value? Meaning you see customer experience, you see chat GPT, you see things changing, auto cars, connected cars, intelligent synchronizations. Less than 2%. Less than 2%. And this is a startling fact that we need to start our business of data engineering and data science there, knowing that. And that doesn't mean that we should not do any data science project or or Gen AI or the cool stuff. But what are some of the pitfalls? I want to talk about that. And as most of you have data science background, you know that data science, what is the majority of a data scientist's job, or how much time a data scientist spend actually developing models? Where does he spend time? Huh? Building the pipeline. So most of the data science time is spent in data engineering, plumbing the data, getting the right data, and then finding the quality and finding out that all of what you have done to get this billions of records of data, only 0.5% had value. Everything else was a waste. So I want to talk about that, and this is where I'm going to spend time today instead of building models. And I'm sure you have heard enough about building models, LLMs, transformers, and how to embark on that. Finally, that I consider icing on the cake. But what has gone into to develop that chat GPT and OpenAI and the APIs that would actually enable value, enable your use case, is the most important thing. Otherwise, we would not be in the business. Who's going to fund our projects? So that's my brief intro. As I said, I spend most of my time in data engineering, building large data platforms, data lakes, warehouses in the legacy world, but now into data lakes and scalable auto-scalable systems. And various use cases there, and we'll talk about the use cases to how to select the use case in order to open up or realize value. So this is something done by Gartner 2 years back, where Gen AI was not part of this stat, and I'm sure Gen AI percentage of success is even lower than 2%. So this is what we have already started, and we spoke about that. So you already know about this. So some of the common pitfalls where we fail, or and this is, we spend money, time, projects, programs, and then we find that 10 other companies like us have done the same mistake. So why do I have to make the same mistake over and over, knowing that this is not going to work? So these are some of the very, very common problems. So problem number one is identification of a right business case or right use case. What would create value from my project? What would actually launch this program that the company is spending 1 million, 10 million, 50 million, 100 million, or hundreds of millions before they see the first dollar returned? And how long is the management, or how long is the business owner going to support? Is he going to last this 5-year, 10-year project, or he's going to be replaced by someone else who doesn't see value in it, and he's going to replace the whole program? So number one thing is the selection of the right use case, and we'll see four quadrants that Gartner has proposed, and we start there. But thinking about the right business use case, lack of business strategy alignment, improper solution design, right data sources, required data quality for the models does not exist, improper resources, data platform pipeline is not scalable or cost efficient. Lack of data governance and value KPI measures of success. So a lot of companies start embarking on the AI and ML journey without defining what is their success metrics or what is their success criteria. When would you call that this project is reaping value? Where would you consider investing more? What is your criteria? That needs to be decided or determined upfront, else you will be chasing your tail. This is a stat I'm using, DSS survey. Look at the failure rate and look at the optimism across the industry, that there is huge optimism that Gen AI would reap value. Almost 23%, 23 plus, they're saying is likely to produce value. This is their expectation. Reality is far, far away from that. So this is the first step, aligning your data strategy. Where is your data? Who are the decision makers? Does the organization actually make data-driven decisions, or you are making or creating a Taj Mahal and you only needed a small hut? So define what is needed, what is going to create value, what is the organizational objectives, and align that with your data, and then launch. What we do is we do the reverse. We see something in the whole world is doing, so we should be also be able to create value. We should be able to be creating, autonomous cars or autonomous decision makers within our systems, healthcare, finance, telecom. So this is a very, very fundamental thing. It seems very cliche, but that's where a lot of failures are there. This is where we select the value metrics or a use case. So if there is a use case of building autonomous cars versus making a braking system work, which one would you take first? And we know the Tesla example, that Tesla is on the roads, but still the autonomous cars are still having to go through all this scrutiny, and there is success questions and what have you. So one of the fundamental mistakes is people jump on, or organizations jump on the most difficult use case up front. Choose the easiest use case with lowest value perhaps and lowest investment. Lowest compute investment. We need to be compute economists. If we are going to be successful data scientists, we have to be compute economists. There is no such thing as free compute. You have always limited resources. Yes, we have a lot more resources than we used to have 10, 15, 20 years when we were doing when we were running on-prem systems. Now we have cloud systems that are auto-scalable or scalable, and we can scale. But there is a huge bill that comes at the end of the month. AWS, GCP, Azure, all of them will send the bill to you. They'll give you huge discounts, but at the end of the day, you are paying millions of dollars. Sometimes company run out of fuel halfway through the project. You can't even write your first model before that the cloud economics have failed or your compute economics have failed. So look at the quadrant, the leftmost quadrant, industrial products and services, low investment and high return. And then government, public sector, education, those financial services, insurance, that's low investment, low value. Life sciences and healthcare, you have to invest a lot, but the return is less. And technology, media, entertainment, and professional services in technology area, they are the most riskiest investments because they're high value, but at the same time, they are very high investment. So people jump on those. Within the industry, you need to select the use case. For example, you are looking at customer experience. Customer experience could be, painless entry and exit activations. If you are looking at the telecom industry, you have a phone that activates and the customer enters the journey, and touchless entry and touchless exit, and the customer starts thinking about or starts browsing about buying a product. You are able to catch him and trap him and bring him through your journey, take him through your CDP, run your models, and give him a personalized offer. All of that can happen, but you choose the first one that is going to bring value to you. And I'll run through a quick example in that. So this is something that needs to be kept in mind, even if someone else, your program manager, is doing that, but you as a successful data scientist need to know what is your success. Can you give a quicker win before you go for a big launch? So this is the long tail problem, very commonly known in the industry. That, and an example used for a pizza, a small pizza shop or a T-shirt shop that's on the street. So they can have multiple reasons, multiple use cases in order to empower their business, customer acquisition, retention, getting more customers, improving the customer experience. So the first thing is acquiring the customer through ads, then the web search. Then you have, let's say in the T-shirt example, where do you place the T-shirts in the store? And then T-shirt demand forecasting. And if it's a pizza, then pizza forecasting, what kind of pizza on a Tuesday morning is sold more? What kind of pizza is sold on a Friday evening? What kind of pizza is sold on a Sunday afternoon? So that when you walk in the store, you don't see rotten pizzas or pizzas that are, no one is buying. So all of these are possible use cases. And if you are the owner of this franchise or this T-shirt company that has stores, where would you start? You start with the most value and easiest one, perhaps, is the ads. You won't invest money in the demand forecasting and the product placement. All of them, you can write models. But at what cost? How much data is required to reach to that model? To get that demand forecasting, you need the supplier, the retailer, the fulfiller, the manufacturer, and the vendors, all of that data working together, and then on top of that, you're running your expensive models on that. And then to make it further more complicated, if you want to develop an LLM and transformers, then that's the next stage. So this is, again, a very simple problem, but we don't get that. When we embark on, we look for very high return and high investment, and then we run out of gas. And in the meantime, we lose the program owner, we lose the investment behind, and we have not properly designed the success or timed our success. So this is the summary. You need a very clear vision, clear business use case, and the selection within your industry. What is that first use case that is going to give value that you can showcase? So if you are a data scientist or you are head of data science in your organization, what is your biggest fear? Investment, money. Who's going to fund this? And you have to make big promises. Most of the projects are big promises, and out of those 100 projects, 85 are going to fail, 15 are going to provide value. So which ones you choose is your choice. So target those smaller use cases, bring value, show and then move on. So show value and then bring investment from the same organization, that you have business support. So you have shown, let's say, value in business forecasting or marketing, then you can showcase that same value for supply chain management. You can showcase that value for accounting or customer experience. And all the others are simple, commonsensical things that we need to do. But since we are driven by technology, we're not driven by value. At times we distract ourselves. So create simple, complex, high value, low value, or instant value metrics, low hanging fruit projects, scalable technology. So the other day I had a call by one of the leading automakers, someone in that organization, and they are developing a data lake, and they want to develop a data lake on-prem without using SaaS solutions. So what is wrong in that? Can it not be done? Will not be scalable or let alone auto scalable. So they will spend time building those pieces of software and compute which is already built, and time to market is where they're going to suffer. They can do that, absolutely. You can have your own CRM solution. You can have your own in-house on-prem data lake based on Apache end to end. But then you need an army of data engineers. You need an army of data scientists. And then, agile delivery, creating products roadmap, and what have everything else falls into place from that perspective. So all in all, selection of the right value-driven use case, and then investing on it and staying away, aligning that data strategy. Also, what are the things that are possible in your decision making when you have to apply brakes? And imagine that an auto-driven car or autonomous car will have that system to apply the brakes. What data would it require? Visibility, temperature, humidity, traffic, lanes, adherence to traffic rules, and then distractions. But let's say if you have soil data of underground or subgrade soil data, would that help you making a decision? As a human being, I don't care what is underneath the asphalt, but that might have a correlation when you develop the model. Meaning that you need to be savvy enough to pick up what data points or what data you are going to acquire. Else, you will spend 90% of the time capturing data that's not going to be used. And this happens very commonly, that they acquire data and sometimes they have this data deluge. They think that without having this data, they become greedy in acquiring data. but not realizing that 95+% of data is not used, not being capitalized, untapped, or it's worthless because there is no correlation we could have developed by now. So that is it. And this is just a very simplistic reminder how we embark on these large projects and choose our best business case and choose our subsequent models for that.